Okay, we can do the fourth problem. We're flying at a heading of 56 east of north. Again, we need to understand that this was north. And if this is 56, then this down here must be 34. And the wind speed is 20 miles per hour out of the west, so the wind is coming straight from the west to the east. So this is 20. We are going 130. We are going, now remember back to when we did these vector problems, these wind problems, we make a parallelogram here. So this is 130 and this is 20, and then when we have a parallelogram, if that's 34, this is going to be 146. And that's going to be our key, because if you paid attention when we did the law of cosines a moment ago, when I go ahead and draw in this resultant vector right here, that's the distance we're looking for the ground speed. The ground speed that we're flying here is going to be, we're flying 130 miles an hour this way, but the wind is pushing us over here, so it's actually going to speed us up. So if you look at the triangle formed there, we can use the law of cosines. I got this 20 and the 130 and the 146. So let's call this x, and I'm going to do the law of cosines. X squared is equal to side length squared plus side length squared minus 2 times side cosine of angle that's in between the two of them. Plug that puppy into your calculator and do some calculations, and I think I get x squared is equal to, my supercomputer kicked it out quick, 21,611. Does that mean that we're flying 21,611 miles per hour? Boy, I hope not. I need to take the square root of that. Take the square root of that and I get 147 miles per hour. And does that make sense that if we're going 130 and being pushed over by a 20 mile an hour wind, that we would go 147 miles per hour? Oh, I think so. Next thing we want to do is we want to figure out the direction we're actually flying, because we're not going to be going this 56. So what I want to do is I want to figure out this little angle right here, and I can do that now by using the law of sines, I believe, because this is 147, and if I want to find that little angle, I can use this angle, which was 146, and I can say, that says 146, can you tell? I can do sine of 146 degrees over the 147 that we found is equal to sine of what we're looking for over 20. Do a little cross multiplication. Now this shouldn't be a very big angle, I'm guessing. And divided by 147. Remember, I got sine of x equals 0.076. You got to do the inverse of that guy. Inverse of that guy, and I get 4.36 degrees. So if you think about, I was going 56 east of north, but then I'm going 4.36 more than that. So I'm actually going 147 miles per hour at, what would it be, 60.36 east of north. So you have to remember that when you set up your parallelogram, you have your resultant vector. That's what the speed will actually be, and then we can utilize the law of cosines. So the law of cosines, don't let it scare you. It looks like it's ugly, but it's not. It's very useful.